Paul McWhorter has a series of lessons on the Raspberry Pi. In lesson 68, he assigned a homework assignment to use an RFID tag to turn on different colors on an RGB LED using the tags and the module that came with the Sunfounder Raphael Raspberry Pi kit. The Sunfounder Raphael Raspberry Pi kit comes with this RFID RC522 module. This module can read and write RFID tags. This picture shows the pin assignments for that module. And here we have listed what each pin is used for. We're using all the pins except number 4, which is used for interrupts. We're not using interrupts in this particular case. Now, I mentioned the RFID tag. This is an RFID tag. The kit also includes a card that is about the size of a credit card that has an RFID tag capability. This shows how the module is wired. I copied this picture from Paul's toptechboy.com page. It shows the wiring for just the module, not the RGB LED. In this case, he has a line going from a 3.3 volt to the power rail, and a ground going to the ground rail. And over here on the right, we show the ground and the power wired in. The other pins are the data pin or SDA, the clock, the out and in MOSI and MOSI and MISO. And over here, the purple is the RST. Now I'd like to show you the wiring that I have for the entire thing. The RFID module is wired the same as Paul had it in his wiring diagram. To that, I've added this RGB LED. Now the one pin second from the left is ground. The other pins are for red, green, and blue respectively, and they are wired to the board through a current limiting resistor for each one. Now the red goes to this pin on the GPIO extender board, and then the green, and then the blue. When Paul said he wanted to use the RGB LED to light up different colors, I thought it'd be more convenient if we had more RFID tags than were included in the kit. On Amazon, I ran across a page that had this pack of 10. Now it only shows 8, but there are a couple more blues than are shown here. So I bought these, and they're quite inexpensive for 10 of them. In the solution, I'm not using all 10. I'm only using, I think, 4 of them. But one problem I had is if you start searching for RFID tags, you will find out there are a lot of different variations. And I was trying to make sure that the tags that I bought worked with this module. Now, one thing you had to consider was down here in this line that it's a 13.56 megahertz tag. All the tags for sale are not at that same frequency. Another consideration is all tags do not include the unique ID identifier already written to them. Some are totally blank and some have the ID already there. Now this ID is something that if it's there, it can't be changed. It's permanent, but you can write additional information. And in this particular batch of tags that I bought, these tags are rewritable. You'll notice if you start searching that all of the tags are not rewritable. To use this module, you need to set up some libraries. One is for the serial peripheral interface, referred to as SPI, and the other is a library for the 522. Now, Paul covers this in great detail in his video. I suggest you watch the video. He starts discussing this at about the 6-minute mark in the video. So I'm not going to repeat all of that again. I have a link to his video below. So let's look at a sample program that he did use in the video that I had to use to accomplish this. Now I mentioned that the RFID tags that I got include a unique ID identifier, and we also need to write some text to the tag. Now his code lets you read both the UID and the text if it's there. If it's not there, or whether it's there or not, you can overwrite it with this code. Now I just copied this code from Paul's site. So what the code does, you tell it whether you want to read or write. The first thing I did was to read it, and you go down here and it tells you to place the card on the reader, and you read it, both the ID and the text. Well, the first time it's done, you probably won't have any text, just the ID. Well, I read the ID and I saved that so that I could use it in the program that I wrote. And then I went back and said I want to write, and then I took a particular one of the tags, maybe a red one, and I said I wanted to write to that tag. So I come down here and I say input the text that I want to write. So I put in there a name and the color red, and I wrote that out. Then just to make sure I did it properly, I went back and read it, and I read the text and the ID again and printed each of those out so that I make sure that I was able to read and write to the RFID tag. Now let's go through the code for this assignment. At the beginning, we set up the libraries just as we did in the example copied from Paul's lesson 68. And in line 8, I set up an index starting at 0. We're going to index through the 5 colors that I have for the tags. Now for the RGB, we have LED, we have the pin assignment set up as GPIO pins 16, 20, and 21. And I set each of those as output. Now I found that working with LEDs in videos, that frequently you turn the video on and it comes on, the camera sees it so bright that you can't tell what the color is. So I've set up something called pulse width modulation that allows us to dim the LED. So what we do is, in this case, we're going to set up a pulse of 1,000 times a second. That means 1,000 times we're going to have a possibility of 1,000 ons. And when we start out, we're going to turn them all off. We're not going to have any of them off. And in this case, I'm going to set the power width modulation for on as 1. That means only one time out of 1,000 pulses will there be the 3.5 volts to that out of that pin. So I set up the 5 arrays for the black, red, green, blue, and white. That means for black, all 3 pins are off. For the red, only the red is on, the others are off. For the green, only the green is on. For the blue, only the blue is on. For the white, all 3 are on. So now for the colors, I have an array of these arrays. I have the black, green, red, blue, and white. Then I have an array of the ID values that I read when we and saved when we wrote to the tags. And I say we have 5 colors. Now we're going to set up a try loop. And with a try loop, I have an exception. If somebody hits a Control-C while the program is running, it will bounce out of my while loop and clean up the GPIO pins and print this message out that we did that. Then inside the try, we have this while loop of true. That means true is always true. So the first thing we do is print a message to tell the user to place a tag on the reader. Now it doesn't actually have to touch the reader, it just has to be rather close. When it sees that it tells it to read the value, when it reads the value, it starts through trying to determine which tag was read. So we go through all of the values. We start out, remember I set index of 0, so we start out with 0 and then 1, 2, 3, and 4. That's 5 values. And when it finds that it matches one, it'll print the ID and the text for that one. And then it has to determine, well, if it read a certain value or a certain tag, which one was it? Well, where the index is when it read it will tell me what color it is. And we use the index for red, green, and blue of 0, 1, and 2. Because up here above we have indexes 0, 1, and 2. So let's go back down. What happens when it determines what those values are, then it writes out to those pins. We use the change duty cycle. The duty cycle is what we call when we tell it how many of the cycles out of the 1,000 we want it turned on. We do that for the red, green, and blue. And we don't need to check anymore. We've already hit one. And then we sleep for a half a second and go back up and ask the user to read another tag. So let's see what happens when we run the program. If we run the program, let's just pick a color, let's say green. You notice down below, it read the tag and wrote out the tag, this number. It's a 4-byte number. And then it says, well, that tag has the name Greg and the color is green. So now it says, well, let's do another one. Well, if we do the red one, well, the name on there was Roger and the color was red. Did it correctly. Let's do the black one. No, that's the blue one. Sorry. It read the name as Bill and the color is blue. Now let's try the white one. The name was Walt and the color was white. And it turned on all 3 to give us a color of white. Now let's try the black one. If we do the black one, it read the name is Bob and the color is black and all the LEDs are off. Now what happens if we use a tag that I haven't set up? Well, this yellow tag hasn't been set up, so let's see what happens there. It doesn't do anything. It just asks me to place a tag on there again. So we've taken care of the tag that wasn't written to. Now to exit the program, if we could Control-C, we exit the program. So it looks like this program is working.